Welcome back, everyone. On today's video, we're going to be covering the topic of linear ODEs. Basically, linear ODEs, they can be divided into two main types. You have your homogeneous linear ODEs, as you can see here on the screen. And you can see that for the homogeneous linear ODEs, all of its terms um, have a y, not counting the zero. This one, it's a y prime. This px has a y. So out of the terms, they have a y. And this is what we call a homogeneous linear ODE. And the good thing about this kind of ODEs is that they can be solved pretty easily. They have a clear formula. Yeah, some of them you can actually solve by separation of variables. But the good thing about this one is that you can, in fact, just have the formula that's given there, the solution, plug and chug, and you will get your answer every time. So that's for the homogeneous linear ODEs. You can see its solution. It's this one. And just depending whatever your px is, whatever that function is, whether it's a function or a constant or etc., basically you just plug it into this integral and you will get your solution. Now, the second type is a non-homogeneous linear ODEs. And in this one, you can see that not all of the components have a y. This is a y, this px has a y, but this r of x does not. And just like this one, this is an example of a homogeneous one. You can see the Rx is on this side, but you can pass it on the other side, doesn't really make a difference. So now we have two terms, Px and Rx, but one of them, it's missing a y. So you can see it does not have a y on its non-zero terms. So the solution is it's different, but it's also done pretty straightforward. You can see we have here the solution. It's the following: we have e to the negative h times the integral of e to the h times the term r of x dx. All of this will be integrated plus c, and then all of this will be multiplied times e to the negative h, where h is simply just that integral of px dx, which is pretty similar to this one. So you can see they're pretty similar in nature, but you just the formula changes slightly whenever you have the non-homogeneous linear ODEs. And these two equations, they are both linear because you can see that the power of all of its basically components is not above a 1. We have a y prime, but it's not like y prime square or anything like that. Same thing with this y, it's not like a y square or something. All of them have a power of 1. So that's what we call them linear. If at any moment these powers have something else that is not a 1, then these equations become nonlinear and we have to apply different rules as we will see in a different video. So let's solve a problem for this one. Let's see which type we have. All right, so we have the following problem. We have y prime plus 3.5y equals to 2.8. And first thing, it's determine the type of ODE. And you can see that for this ODE, there's a y here, this term has a y, but this term does not have a y. So if that is the case, it means that this will be basically a non-homogeneous. And well, we know first, before that, we know it's linear because none of its powers are above a 1. So then we say that this will be a linear. And what kind of linear? Well, since there's only a y here, and this one does not have a y, then we know it's a linear non-homogeneous. Okay, so now that we do that, now that we know which type we're working with, we know that we need to find then our p and our p of x and r of x in order to then solve for our equation. So this is pretty straightforward. So for this one, our p of x will be basically this one. So we have then here that p of x is equal to 3.5. How do we know that? Well, if you look at the original formula over here, this is the term p of x, and then this is the R of x. And then for our R of x, let's look at it. So that's P of x, and then R of x will be equals to positive or negative 2.8. Which one do you guys think? You can see that in the original formula, all the way over here, the R of x, it's on this side as positive and on this side as negative, which of course makes sense, right? If we send this one to the other side, will become negative. So since this is following this format, then we know that the R of x, we can write it as positive. So R of x is 2.8. And it's just that number in front of the y. Or yes, it's just that term. Function number, whatever it might be, is just that section. Pretty straightforward, pretty simple. Okay, now we know that, we can find h. And from here, we know that h, it's simply the integral of p of x dx. So for this case, is the integral of 3.5 dx, which is pretty straightforward. We're going to get just 3.5 x. And that's for h. Okay, now we need to solve for y. And to solve for y, we use a formula, which it's y of x, which equals to e to the negative h times the integral of e to the h times r of x dx plus c. So let's just substitute in the values. So this is equal to e to a negative 3.5x, which then is multiplied times the integral of e to the positive 3.5x times r of x, which is 2.8 dx plus c. All right, let's continue simplifying this. And then we're going to have e to the negative 3.5x times, we can factor out that 2.8 from the integral. 2.8 integral, this is e to the 3.5x dx plus c, right? And so this will be e to the negative 3.5x times, well, that 2.8, it's still there, 2.8. And then the part for the integral is just, it's just a simple integral. So that will be e to the 3.5x over 3.5 plus c. And then all we need to do right now, after it's like this, you can see we did the integral. So after, we are going to basically multiply and distribute. So this one, we're going to multiply times this term and also multiply times that plus c. We're going to be doing that. We're going to do the multiplications. Once again, this times this term and times the c. We're going to multiply that. And let's see what we get. So we have then, you can see we have negative 3.5 to the x times positive 3.5 to the x. Since they have opposite exponents, right, they're going to add up and they're going to cancel out, which is going to have e to the 0, which is just going to end up to 1. So we're going to have here then end up with 2.8 over the 3.5, right, because the e to the x's, they cancel, plus c times e to a negative 3.5x. Do not forget that because we distributed that. And now we can just simplify even further, and we'll get that y of x is equal to, well, if you simplify the 2.8 over 3.5, that's 0.8 plus c e to a negative 3.5x. And this is the solution to our problem. So you can see this problem is pretty straightforward. It's not complicated at all. It's just a matter of defining whatever your p of x and r of x are, and then just following the given formulas. It's pretty straightforward. This apply if the p of x and the r of x, if they're functions, they also apply. nothing complicated. So let's do the next problem, so you guys can get this a little bit more in depth.